Okay, so in the first video, we were just kind of like going by intuition, and I would say, 180 degrees. Well, mentally, that's equal to halfway, because that's easy to know.
Okay.
Right? Which means it's equal to the total length of the circle, the unit circle, but then I divide by 2, because that's how I get half of something. And in the end, pi was 180 degrees.
Okay.
Okay. And that's a great start for what we're looking for, which is a formula.
Okay.
For conversion. I don't want to have to like play this little game of imagining a runner and thinking how far they're running around. The basic idea is if I have some degree angle measure, this is some subdivision, some number that's dividing the unit circle.
Okay.
I'm going to use n. So I'll use capital D for degrees.
Okay.
Whatever. And I know that D represents 1/nth of the circle.
Okay.
Okay. Before we had 180 degrees represents 1/2. Okay. And we had 90 degrees, ... 1/4. And we can put a lot of numbers that are like easy to deal with, right? But then I throw something at you, 14 degrees. What's that in radians? I mean, you can't be like, it's ridiculous. It won't be first of all, it won't be 1 over an integer.
Okay.
All right. So what we really need to do is think about this mental thing that we're doing, and we need to like turn that into some formulas.
Okay.
Okay. Before we started recording, I said, what was the one I wanted to do? 30 degrees? Oh, I said the key angles, the degrees angles that we really need to do first off are 0, 30,
45, 60, 90, ...
Right, and we kind of have an idea that if we can handle these, we can handle the rest of them, because we'll figure it out. But let's do whatever we can. I want radians. I want to make a list of what these things are. We already said that 90 was pi over 2. Because I'm going to move it up a little bit here. We said that 90 degrees was 1/4 of the circle. And, hold on. So we said 90 degrees equals 1/4 of 360. Right?
Yes.
Which means our mystery value, the number of radians, will equal 1/4 of 2 pi. So we've got to figure out what's going on. Where does this 4 come from? Where, we want to equationize this. Yeah, we want to make it into, just an algebra thing that we don't have to think. You just divide by 10 or something.
Okay.
Okay? That's what a formula is, right? A formula is something that works whether we like it or not. Okay, but maybe we can't do that just yet. We can still fill in this chart. What's 60 degrees? I'm gonna make this pi over 2 look better. I won't erase. What is this?
Try it again.
No, it's. They came out with a new version. Anyway, that's a 2 with a shadow or something. I'll tell you what. Here's what we'll leave it. It's pi over 2. Audience, that's pi over 2. We'll quit worrying about it. What's 60? We can zoom in. 60 degrees. Well, how did I figure out 90? first
That was pi over 2.
first thing I did with 90 was I compared it to 360.
Which is 1/4.
Right. What'd I do with that 1/4? Where did pi over 2 come from? What's the whole circle on the unit circle?
You had 2 pi over 4.
Right, in the end I had 2, not in the end, right before the end I had 2 pi over 4.
Yeah.
In the end I had pi over 2.
Yes.
Right? But this pi over 2, where did it come from? It came from 1/4 of 2 pi.
Okay.
Just like 90 degrees came from 1/4 of 360.
Mhm.
I mean, everything I've written so far, it's clear, right?
Mhm.
So, 60, how do I compare that to 360? What's the appropriate fraction to talk about if I want to kind of do the same thing with 60? 60 is what fraction of 360?
60 is
Let's
1/6.
1/6. Okay, and you did that kind of intuitively, but I'm gonna actually take what I said and equationize that. I said
Equationize.
60 is what of 360?
It's 1/6.
Okay,
60 over
this
360.
sentence in English, I'm gonna put quotes around it, translates to math. 60 is easier to translate. Same in both languages.
Yeah.
Is English version of equals.
Okay.
What, in everyday speak, we use a variable for that.
Mhm.
And then there's this weird thing where they say of means multiply, and I just take their word for it because it works every time. But I never really understood that. I don't really get it.
I learned that, but
I know they tell you and you memorize it, but it's like
who knows why?
when somebody says how much less than or how much more than, the fact that that's addition and subtraction is really clear to me. But the preposition of, I don't know. I digress. 60 equals x times
360.
360. Now can you tell me what fraction it is? It's
1/6.
easy. Right? So x is 60 over 360. And our reducing powers tells us that, I said that with mispronunciation. X equals 1/6. What do I do with the 1/6? Where does it go to tell me what 60 degrees is for radians? I got an answer. I'm pretty sure I got a good feeling about 1/6. It's gonna
I have a good feeling.
do something important with its life. What does it do next? What's all the way around the unit circle?
360 degrees. So pi.
In radian. In radians, all the way around the unit circle,
What was pi?
2 pi times 1.
2 pi.
All right, circumference of the unit circle,
2 pi times.
2 pi times
one.
1. I can do that in my head. It's 2 pi. All right, so 1/6, rather than being the fraction of 360, this fraction is a sixth of the circle, whether we're talking about degrees, radians, or light years, or whatever.
Okay.
1/6 of the circle looks the same,
Okay.
right? So now we care about 1/6 of, which means multiply,
Okay.
2 pi, which, again, our reducing powers tells us what? Which 1/6 times 2 pi?
1/6 times 2 pi.
You're not too big on
2 pi over 6.
2 pi over 6.
Pi over 3.
The reducing, yes, there we go. I shouldn't put you on the spot because I know you're much more prolific with a pencil. The stuff in the head is hard. Pi over 3. All right, so let's sort of go ahead and start to mark this out a little bit. What we figured out, and I'm going to draw some stuff on a unit circle here. And that's a unit approximation of a circle. We figured out the North Pole. We figured out that thing. And we figured out 60 degrees, which is like kind of here.
Ish.
And we figured them out in radians. And do you remember? It's away from the screen now. A right angle is 90 degrees, but at the same time, we call that pi over 2 radians.
Okay.
Okay? And then I'll use a different color for pi over 3. What's a good way to draw pi over 3? I'll show you. Mark that, and then you know that pi over 3 is like right there. When I say mark that, that's like x equals 1/2.
Okay.
Right? See, so that's 60 degrees now, or you know, what I mean, it's a version of 60 degrees because the lines are different. The lines are all skewed; they're not different. Anyway, I got distracted. This right here is a 30, 60, 90 right triangle. The way, from now on, if somebody says, hey, you draw 60 degrees, you start at halfway between the center and the circle. You know that that's 1/2. You draw the radius of the circle, and then you connect the line between 1/2 and the top of the circle, and this is now 30, 60, 90 right triangle.
Okay.
Because if I were to reflect it, you gotta remember this was from like 3 weeks ago or something.
Yeah.
This is foundational knowledge of trigonometry. But right now it's just artistry of how to accurately draw 60 degrees. We care about the radian measure. We just did it. We said that 60 degrees was how little kids talk about it, and adults say pi over 3.
Okay.
What about 45? So I can draw 45.
Yeah.
And I can write a thing there for the angle.
You should put a color code down the side.
45 degrees. No, the color code is implicit, right? 90, 60, 45?
Yeah.
Except for, look, I spoiled it when I switched between red and orange. Anyway.
It's okay.
If you're watching this, or if the people who are watching this, they don't like it, they can call customer service, right? So we got 45 degrees. I mean, that's our goal.
Yeah.
I'm going to say 45 degrees equals how many radians? Let's try to do this a little systematically, right? We said that 45 equals 360 times x.
Okay.
And then later on, we said our radians were equal to x times 2 pi. And you know what? Actually, there's nothing special about this number 45. Let's call that the number. We should give it like I was going to say a sinister thing. I don't know. I've never tried this rainbow. I wonder what happens when I do this.
Good question.
I know it's a good question. I don't get it.
I
It's just
don't
white.
think you can.
Oh, I didn't switch it. There we go. Let's erase the white. Okay. In the middle of the video.
It's still white.
How's that? What is going on there? Oh, it just means I get to pick the color.
Oh.
That's dumb. Okay. Never mind. Sorry to. Well, we'll use what I picked anyway.
Oh well. The color.
The degrees are given to us, right? 45. This is D. And what I'm looking for with this X over here is pick a good color for X. X is telling me what I am about to multiply times 2 pi.
Okay.
Right? So how do I get a formula for X in terms of D? There's a whole calculator button devoted to that alone, and it's division.
Oh.
Right? Divide both sides by 360.
Okay.
So X is D over 360. In our example with 45 degrees, 45 over 360 reduces to... So you think about that, and I'm going to rewrite our setup. So we have D degrees, and I'm going to call it theta radians,
Mm-hmm.
and I'd like to convert that, meaning I'm given the degrees, and the result of my formula needs to be radians.
Mm-hmm.
I want to say theta equals,
Okay.
well, we know that theta is some fraction of 2 pi.
Okay.
What did we name that fraction? We named it x. Right?
Mm-hmm.
So, for example, when d was 90 degrees, x was 1/4. Because 90 degrees is 1/4 of the circle.
Okay.
Okay? How can I come up with a systematic way to solve for x? What equation governs x? Well, we know that our d degrees
Okay.
is the appropriate fraction times 360.
Okay.
Solve that for x, and I get that x is d over 360.
Okay.
Okay. Notice that in both spaces, I've got the angle that I'm dealing with is some fraction of the total. The only difference is that 2 pi is the total with radians because it's the circumference of the unit circle. All right. We're almost there.
Okay.
This guy, oh, I should change my marker color. It's ready to join with the other formula.
Okay.
Right, so I need to take x, identify that these two things are equal, and substitute. So theta equals d over 360 times 2 pi.
Okay.
Okay, and now I have it. I have a formula. You give me d, I'll give you theta. But usually it's written like this. Pi over 180
Okay.
times degrees. The given degrees will give us the same angle but measured in radians.
Okay.
Let's do an example. Just to prove it, I can't stop the video without an example. Give me an angle measurement.
On the unit circle or
One that we already did. We already did 60 degrees, right?
Yeah.
Let's see if it works. Okay.
Okay.
So 60 degrees, I want to convert that to mystery value radians. Okay? Well, according to my recipe, 60 goes there.
Okay.
Okay? So my answer is pi over 180 times 60.
Okay.
Which is a stupid way to write 60 pi over 180. And I feel like there's some reducing.
That's possible.
Yeah, I don't know. 60 and 180, I believe they have common factors.
Yes, they do.
So anyway, if you want, you can pause and figure it out. But I'm going to spoil
It's 1
it.
pi over 3.
Exactly, and we just did that, right?
Mm-hmm.
If we go all the way back to, where's the circle?
A long time ago.
Did we label it? Yeah, there in orange. It was orange earlier. This right here was 60 degrees equals pi over 3.
Okay.
All right? And there's going the other way. There's changing radians 2 degrees. That one's almost easier because I've even already told you the formula there. Pi equals 180. This is how I do radians 2 degrees. And it's a long video.
Mm-hmm.
I hope you made it this far. If you made it this far, you know, you deserve the information I'm about to give you. So what if I wanted to do 2 pi over 3 radians
Okay.
and turn that into degrees? I just plug in 180 for pi.
Really?
So that one's the easy one. And turns out that is 120 degrees. Or you could have said, hey, why are you wasting my time when all I have to do is multiply pi over 3 by 2? So there, once you know a few of them, you can kind of build all of them at will. Okay?
Okay.
See what happened here at the end?
I think so.
Okay. 20-minute video. That's too long for videos. But we'll be alright.